Okay, kiddos, here is the last part of our Introduction to Simple Harmonic Motion lesson. On this page of the note says, please solve examples 1 through 5 here. Thank you. Examples 1 through 5 are these, so you could put this on pause, and there are the questions. So this is from a regular physics textbook, and they are designed to be just kind of plug and chug, meaning straightforward once you know the formula. So two formulas we know. We have F equals negative kx, and then we have that the potential energy stored in the spring is 1/2 kx squared. So I think that we're just going to be plugging into those. Let's read through each question and make sure, and then you can go ahead and solve them. So how much force is necessary to stretch a spring 0.25 meters when the spring constant is 95 newtons per meter? Okay. 2. A spring has a spring constant of 56 newtons per meter. How far? So we know the spring constant. How far will it stretch? We're looking for x when the block weighing 18 newtons is hung from its end. So that would be the force. Question 3. What is the spring constant of a spring that stretches 12 centimeters? So that is the stretch, and you'd put that in meters. When an object weighing 24 newtons, so that would be the force stretching the spring, is hung from it. We're looking for spring constant. And when you get spring constant, just make it positive. This, again, negative is due to the fact that this and this, these are going to be in opposite directions, and that's just sort of implied. Question 4, spring with a spring constant of 144 newtons per meter is compressed by a distance of 16.5 centimeters. So the displacement you're going to put in meters. We know the spring constant and how much elastic potential energy is stored. So we're over here. Spring constant, displacement, elastic potential energy, or potential energy stored in the spring. And then question 5 looks like this as well. Spring with a spring constant of 256 newtons per meter, how far must it be stretched? So we know the spring constant. How much must it be displaced to give an elastic potential energy of 48 joules? So you'll be solving for x. Alright, so go ahead and do that, solve them, and I'm about to switch to the next page which shows the answers. So put this on pause, solve them. Do not spoil the surprise. So now you've solved them. Hopefully these answers are looking good. And I think that's all I have to say. So good luck, and I will see you in class.